Supplemental math videos from Circle Christian School. Solving logarithms, part 2. Again, where's the x? You got to figure out whether you need to log the equation or power it. Do it. Now we're going to go find x in the logarithm, which means we're going to have to power it up. So you're always going to take a look, see if you don't have same logarithms. And in this particular case, we have a log 2 on one side and a log 2 on the other side. Hallelujah. That just means we have to find equal equations here, because a log 2 equals a log 2. So we just have to go x plus 4 equals 3x minus 5. All great Algebra 2 students know that they take away an x first. And then we end up with our 4 and the 2x minus 5. Then we're going to add 5s and we're going to add 5s. Yeah. Easy peasy stuff. 9 equals 2x. Don't you wish they could all be this way? So x equals 9 over 2. Or for you that can't get away from your calculator, 4.5. All right, the next one here, you'll notice different things on different sides. And again, just like anything, sometimes we have to get a condition all by itself. And this logarithm actually has something to it, a 2 being multiplied to it. So before we could ever begin, we're going to have to divide both sides by a 2. So now we end up with log 4x. Got the logarithm all by itself, equals 5 over 2. X in a logarithm, going to power it up. I take this logarithm and I give it a base 4, and I power it up, which means I'm going to give this guy a base 4 and power it up. Now, anytime you power up a log, again, it ends up equaling 1. So it cancels out. And that leaves us with x 4 to the power of 5 over 2. So x equals 32. And again, you can always just George Polya it. 2 times log 4 32, does it equal 5? Okay, log 4 32, and we can think base 4 power to 32, and then that twice. Or you could do the little change to the base thing, which is what I'll do. I'll go log 32 parentheses divided by log 4 gives you 2.5. Going to multiply that by a 2, and all great Algebra 2 students yet sang the song of hooray because they were right after George Polya did it. All right. Next one, got an ln going on here, and an x with an ln, remembering that that's a natural logarithm. And we have to get the ln guy all by himself with the little x. So we're going to have to divide out the 20 and divide out the 20. So we end up with ln 0.2x equals, and we can get rid of the zeros here, so 3 over 2, or if you want to keep to the decimal, you can go 1.5. Okay, the opposite of an ln is an e. So I'm going to e and power up the logarithm, which means I have to e the other side and power up the answer. And so we get 0.2x equals e to the power of 1.5 5, which we know we got to divide by the 0.2. Again, it can be very calculator driven. Just follow your steps in order here. Second key, E, power key, 1.5, enter, divide by 0.2, and we get x equals 22.408. I like giving it a couple little things out behind because that just gives you more of an exact answer. And again, you can George Polya it, put it back into the original equation, see if it makes a true statement. 22.408. My 0 disappeared. There we go. Does it equal 5? No. What do we have? 30. There we go. You try it. See if it works. Now, every once in a while, we're going to get kind of a crazy one here. And, of course, Mr. Bill and Mr. Bob are just going to be beside themselves. Oh, yes. And note what you have here is actually an expanded logarithm. It's been expanded. So, to deal with it, what we're going to do is just condense it before we begin. Happens every once in a while, no big deal. And so we're going to take our base here, our base logarithm, so log 3, where the fancy people would go log base 3. Have the minus sign, so I know it's that little division one, so I have a 2x over the x minus the 3, and it equals 1. All right. So the x is still hanging around in the logarithm, which means I'm going to have to power it. Mr. Bill and Mr. Bob know that. And so we're going to give it a base of 3, power up the log, which means we're going to have to power up the answer. And so we end up with 2x, here it is, x minus the 3, equals 3 to the power of 1, which everybody knows is just 3. Okay, so I can just see Mr. Bill over here is having a spaz attack because he goes, "What do I do now, Mr. Bob?" And Mr. Bob says, "Well, Mrs. Washington always says a fraction equals a fraction. Let's cross multiply." So we have a 2x equals 3 times the binomial, x minus 3. Back to algebra again. And all is happy in Mr. Billville. Alright, so we get 2x equals 3x minus the 9. Yeah. Got a minus a 3x, got a minus a 3x. Oh, yeah. So we get a negative x equals a negative 9, and everybody goes, x equals 9. And to George Polya it, we just plug it back in, and we have a log 3. 2 times 9 is 18. Does that equal log 3 9, oh, equal, sorry, minus. No wonder I was going crazy. I need my white out. Boop, boop, boop. Okay, white out. He says minus. Makes better sense. Good deal. Okay, 9 minus a 3. And does that equal a 1? All right, well, let's see. That gives us a log 3 18 over the 6 equals log 3 it does equal 1, and all's good in Mr. Billville. Oh my, tragedy has come to Mr. Billville. And as the girls say, we told you that Mr. Sluggo was up to no good. Let's see what's happened in Mr. Billville. All right, Mr. Sluggo was discovered in a motel room at 10 p.m. and its temperature, or his temperature I should say, was 85 degrees. Not good on most days, especially since now he's kind of like horizontal instead of being vertical, if you know what I mean. So 3 hours later, Mr. Sluggo's temperature was 78 degrees. The temperature of the hotel room is a constant 65 degrees, which just tells you that it was a very cold day in Mr. Ville. So the formula is Newton's law of cooling, which happens with a lot of things, you know, a pan of boiling water on a stove and etc. You know, when people started just doing that, they were able to do things with all sorts of temperature, body temperature being one of them. Is a standard formula of KT equals ln T minus S over initial T minus S. Now the big thing is just to know what all these little K's, T's, and S's mean. Well, the little t is the number of hours that has elapsed. T initial T is the temperature at the time of find, or whatever you want to start as temperature, 85, just remembering that for a body at the exact time of death would be 98.6, our normal temperature. T, where we ended up after 3 hours, was 78. You're just kind of measuring what's going on in time here. And of course the S is the temperature of the surrounding area. That's why it gets to be S, surrounding area. So the first thing we have to do is find the constant. Because the surrounding area temperature is the variable here, we have to find what kind of scale is happening. That's K. Finding K is known as finding a constant variable within certain conditions. Therefore, it will work if those conditions are kept the same. So all we're going to do is actually replace the lapse time of 3 hours inside here so that we can find our constant variable for the conditions that have been set, basically the 65 degrees and the time. So I've put the 78 in because that's what happened over the 3 hours here, minus the 65, and then 85 because that's what he was found at, minus the 65. Gives us the 13 over 20. And using our handy dandy calculator, we just gives us this nice long decimal, which I'm going to keep as it is because I'm going to just use my calculator. You'll see it's a negative number, which gives us that K ends up, it's a negative number here. So we want to get the K by itself, so we're going to have to divide by the 3's. And so our constant K happening inside here is a negative 0.144. Now this is going to be able to allow us to do all sorts of tricks with poor Mr. Sluggo and find out a few things. So putting it back into, again, the original equation, because what we want to do is find the time of death. We know we had 3 hours lapse from 10 o'clock till we got the 78 degrees. So now we need to find out how much time it took to get from the 98.6 to the 85 degrees. So using your handy dandy little calculator, going to do the ln 20 divided by the 33.6, and you just hit enter, which gives you a negative number. We have to divide out the negative 0.144 to get the t by itself. And we get approximately 3 hours, 3.6 hours here. All right, so walking back from 10 o'clock here, first hour takes us to 9 o'clock. Second hour takes us to 8 o'clock. Next hour takes us to 7 o'clock, and then we got to walk of a clock here, which is 6/10 of an hour. So that's what I'm going to do, is take 6 divided by 10 and times that by 60 minutes, which is 36 minutes. So 7 o'clock take away 36 minutes gives me a time of, what is it, 6:24. Now I know when to look at the surveillance cameras around Mr. Sluggo's motel room, hoping that there were surveillance cameras around there, and we may find out which person in Mr. Belleville did this dastardly deed to Mr. Sluggo. Okay, so now for part C, what was the temperature of the course 2 hours after the death? Which is just kind of like, well, we can figure out just some fun stuff from here because we're with CSI, like Lisa's brother is, and we can put on our badges, and I'm just going to have you go to work, and it should match the answer in the book. Okay, guys, have some CSI fun. By the way, who do you think did the dastardly deed to Mr. Sluggo?